Hello everyone, I am Disha K of CSE Cybersecurity Department from Sri Venkateshwara College of Engineering, Bangalore. Today I am going to discuss about the Heisenberg uncertainty principle. Introduction to the Heisenberg uncertainty principle. Heisenberg uncertainty principle is a fundamental concept in a quantum mechanism. It states that there is a limit to precision with which a certain pair of physical properties of a particle can be simultaneously known. This principle was formulated by Werner Heisenberg in 1927. Mathematical formulation. Mathematically, the uncertainty principle can be expressed as delta x, delta p greater than h by 2. Delta x represents the uncertainty in a measurement of the position and delta p represents the uncertainty in a measurement of the momentum. Complementary properties. The uncertainty principle applies to the pair of a complementary properties such as a position and momentum, energy and time, angular position and angular momentum. It implies that the more accurately we can measure a one property, the less accurately we can measure the other property. This due to the wave particle duality of the quantum mechanism. Wave-particle duality. According to the quantum mechanism, the particles such as electrons and photons can exhibit their both wave-like and particle-like behavior. This duality means the exact position and momentum of the particle cannot be simultaneously determined with arbitrary precision. The uncertainty principle reflects the limitations of our knowledge about the nature of the particle at the quantum level. Experimental evidence. Experimental verification of uncertainty principle has been demonstrated in a various experiments. One example is a famous double slit experiment where the interference pattern observed indicates the wave-like nature of the particles. Another example is an electron microscope which uses the electron wave to the image object with a high resolution. Implications for measurement. The uncertainty principle places a fundamental limit on a precision of the measurement at a quantum level. It implies that there are inherent uncertainty in our knowledge of a physical world. This has significant implications for the field such as quantum computing where the precision control the quantum state is essential. Application in a technology. The uncertainty principle has a practical application in a various technological field. It influences the design and operation on an electron microscope, atomic force microscope, and other precision measurement instrument. Understanding and counting for the uncertainty principle is crucial for accurate measurement and advancement in a field. Quantum entanglement. The uncertainty principle is closely related to the phenomenon of a quantum entanglement. Entanglement is a property where two or more particles become a correlated and system of a one particle cannot be described independently of the others. The uncertainty principle helps to explain the non-local behavior observed in the entangled systems. Heisenberg uncertainty principle versus the observer effect. The uncertainty principle should not be confused with the observer effect. The uncertainty principle deals with the inherent limitations of a simultaneous measurement, while the observer effect refers to disturbance caused to act by a observing a system. Both concepts are important in understanding the behavior of the quantum system but addresses the different aspects. Behind the classical physics, Heisenberg's uncertainty principle challenged the deterministic overview of the classical physics. It highlighted the probabilistic nature of the quantum mechanism and introduced a new understanding of the physical phenomena. The principle of the way for the development of the quantum theory and revolutionary over understanding for the microscopic world. Quantum superposition. The uncertainty principle is closely connected to the concepts of the quantum superposition. Superposition is refers to the ability of the quantum system to exist the multiple states or a position simultaneously. The uncertainty principle places limits on the precision with which we can determine these superposed states. Quantum mechanics and microscopic world. Quantum mechanics is a branch of the physics that deals with the behavior of the matter and light on a subatomic and atomic level. The properties of an atom and molecule and their the fundamental particles like protons, neutrons and electrons. While uncertainty principle is primarily applicable to microscopic level, it has implication for the microscopic world as well. In a certain situation, the quantum effects can at a large scale, including the phenomena such as superconductivity and superfluidity. Understanding the uncertainty principles helps the grasp the boundary between the classical and the quantum physics. Quantum interpretations. The uncertainty principle has been subjected to the various interpretations within a field of a quantum mechanism. This interpretation includes the many word of interpretations and the pilot wave theory. While this precision, the interpretation remains the topic of a debate. The uncertainty principle is a universal accept the concept in a quantum physics. Future direction. Heisenberg's uncertainty principle continues the cornerstone of the quantum mechanics. Ongoing research aims to further understand its implication and explore the boundaries of the quantum uncertainty. Advance in a technology and experimental technique will likely more light on the fundamental nature of the uncertainty in a quantum realm. Conclusion of the Heisenberg uncertainty principle. Heisenberg uncertainty principle revolutionized our understanding of the microscopic world. It established the limitations of a simultaneously measurements and introduced the probabilistic of the quantum mechanism. The principle continues to the shape our understanding of a quantum phenomena has a practical application in a various field.